Hey there folks, Mr. G here with another educational video. This time we're going to be talking about chemical versus physical changes. So we've already talked about chemical and physical properties, but now we're going to look at the changes that can occur, either chemical changes or physical changes. And those will be tied to a lot of chemical and physical properties. Before we jump in though, I'd like to remind you today's date is November 23rd, and this is going to be page 3 of our notes so far. Let's start with the physical change. A physical change is where some substance is getting altered, but without changing its chemical identity or composition. This can be something like a change of state, whether we're melting something or evaporating. So, for instance, water can change from solid to liquid to gas without changing its chemical identity, the fact that it's water. We can have something dissolving. So if you put salt in water, it will dissolve into the water. We'll get some salty water, but that hasn't changed the fact that it's salt and water inside of it. It's dissolved, but those two pieces, the chemical identity of the salt and the water, are still there. Mixing, so if you had, say, like some sand and some rocks, and you mix them together, that doesn't change what they are, doesn't change the chemical identity of those rocks. Cutting, breaking apart, so you take a piece of wood, cut it in half, that doesn't change anything. Same thing with diluting. So if I have, let's say, a little bit of hand sanitizer, right, a little bit of alcohol, and I dilute it by adding some water, similar to dissolving, this doesn't change the chemical identity or the composition. All that changes is how much water we have compared to how much, say, alcohol is in it. A chemical change is when the type of matter changes to produce different types of matter. We have reactants, substance that we start with, and products. So different things that we start and end with. And some evidence that a chemical change has occurred is new colors, smells, textures, temperature changes. So when you mix things together, sometimes you can produce a chemical reaction where something will heat up. If you've ever used like hot packs, where you break them and then they get warm, that temperature change tells you that a chemical change is occurring. Some sort of solid being formed, bubbles, gas, light being produced. These are all indications that a chemical change has occurred. Now, these aren't always true. Sometimes that, for instance, a change of state can cause colors to change, or when you dissolve something, so if you had, say, a red powder and you dissolve it into water, sometimes the water will turn red. So these aren't always true, but they're good guidelines. These are usually what happens when a chemical reaction occurs, and oftentimes you'll have many of these happening at the same time. And how do you tell that the products are different than the reactants? The key here is that the products will have different chemical and physical properties. So those things we've been talking about for the last few days. If there are different chemical and physical properties for our reactants, that tells us we've got new substances that are different from the substances that we started with. And if we look at some common changes that take place in a kitchen and identify if they're chemical or physical, if we water down a glass of orange juice, we already talked about diluting. This means like watering it down. So by adding more water to our glass of orange juice, we're not changing the fact that there's still some orange juice and still some water. We haven't changed the chemicals, the chemical identity. This is a physical change. A cast iron frying pan rusting when it's not being kept dry, this rust is a new substance, which tells us that this is a chemical change. Cooking bacon, this is actually a combination of things. So when we cook bacon, we're actually changing the chemistry of the bacon itself. That's the smell that you get when you cook bacon. The color will change. It'll turn kind of more of a dark brown color. Different texture, it gets kind of crunchy sometimes. But you also see that some of it is also a physical change. So if you notice when you cook bacon, a lot of times there's some grease at the bottom. So that's actually fat turning from solid to liquid. So we get a combination of physical and chemical changes. We get new colors, smells, textures, but we also get a change of state here. Food decomposing in a compost bin, that's definitely chemical. And if you've ever had a compost bin, you definitely notice some new smells, new colors, and new textures. Bread becoming toast in a toaster, this is also a chemical change. We get new colors, smells, and textures. It goes from soft to really kind of crunchy. That's evidence of a chemical change. Steam coming from a kettle of water, this is a physical change. This is water changing state from liquid into gas. It's evaporating, and that's a physical change. But it doesn't change the fact that it is still water, even though it's a gas. Making popcorn, this one's a little tricky. It turns out that this is actually a physical change. When we make the popcorn, what ends up happening is we're actually the same chemicals or the same chemical identity, the corn itself, is just expanding. So I know it's not listed here, but cutting or breaking apart, another thing could be is expanding. So all that we do when we pop popcorn is we actually make it expand. So this is technically a physical change. There might be some chemical changes happening as well. You get definitely different colors, but I guess it's more on the inside. Smells and textures, but those mostly come from the popcorn burning, which is a chemical change. Mixing juice crystals in water. So this is the same as mixing or dissolving. And we know this is a physical change. One last thing I'd like to mention about chemical reactions. That's what happens when chemical changes occur. We have a chemical reaction. This is the same as a chemical change. And it's important to know that there's this law of conservation of mass. Conserve, this means to stay the same. And this says that matter is never created or destroyed in a chemical reaction, that the total mass at the start equals the total mass at the end. So we can't create or destroy matter, the stuff that's there. We can just turn it into different forms. So different reactants, different products. You'll learn about this a lot more in grade 9, grade 10, and especially in grade 11 chemistry. But I want to go over this a little bit right here. So one famous French scientist, Antoine Lavoisier, performed some chemical reactions in sealed containers to test this out. So we measured the mass before and after. So this one, we have a flask here that's sealed with some oxygen and some mercury. And afterwards, after some heating, we had, instead of this silver liquid, we had a pile of red powder, stopper, and then still some oxygen. In this case, our reactants, the things we started with, were mercury and oxygen, and at the end we had mercury oxide. So this is a chemical where those two are combined together. We can know that this is a chemical change because the products have different color and texture. We went from a liquid to a powder, and we went from something silver to something red. If we measured the mass of these two flasks, though, our law of conservation of mass says that they would have been measured to be the same. Same mass, same amount of stuff. If we put them on two scales, we would get the same number. And why was it important that the container be sealed? So thinking about how it would change if the stopper was removed, well, the air would be able to move in and out of the flask. So that means the mass wouldn't be the same before and after heating, right? If this air is reacting with the mercury here, but then more air can come and then leave, the mass that's inside of this, and yes, air does have mass, it's made up of matter, then the mass is going to be different. So it's important that we put the stopper there, so that it's just the air and the mercury inside at the start and the end, that nothing has come in or gone away. And then some safety concerns here. For one, mercury is poisonous, so you don't want to drink it, you don't want to eat it. And heating sealed flasks can cause them to explode. If you've ever done this, heating up a sealed container, they often say this on like spray bottles, don't heat it up because it will explode. And that's because the air in here would expand. We'll learn about this a little bit in some coming lessons, but when you take air and you heat it up, it expands, and eventually that expansion can cause an explosion. That's the end of our video here. Please make sure you complete these notes for yourself and check Teams for the daily homework and any other assignments that you have to complete. See you all in the next video.